Okay, so what I'd like to do today is I'd like to kind of walk you guys through the DO lab for this class. There's a couple ways to get to this assignment. The first thing you can do is go to course materials, click on content, the chemical oceanography unit, and then click through the pages until you get to the DO lab. What I like to do is I just like to I like to click on the button and I just like to scroll down. And you see here I have lab dissolved oxygen. I have that it's on page 8. So that means if you have any like questions or you're not really sure about dissolved oxygen, or there's any of the questions in the lab that are giving you some trouble, if you go to page 8 of the chemical oceanography module, it probably is going to be discussing dissolved oxygen, and it'll give you some kind of background information on these concepts. And then I have the instructions. As you can see here for other assignments, when I finish this video, I'll have the video link here for you, the document that we work on, I'll put that here for you, and I'll put a YouTube link to the video too, just in case. If there are any frequently asked questions that students have asked me, I'll put those there as well. So far I don't really have much here for this lab, but once we finish this video there'll be a little more information here for you. So I'm going to go ahead and click this and see what we've got going here. Okay, so first thing I'm going to do is I'm going to download this document, and I'm just going to download it to my desktop. And it looks like it downloaded a PDF, even though it says it's an RTF file. So let's see what we've got going on here. Okay. So what we're going to do is I'm kind of going to talk about it with you, and then we'll go from there. So let me see if I can bring up, this is the PDF file. Okay, so what I'm going to do is I'm going to make a Word file for this. That way you guys have something that you can edit. So I'm going to pause the video and I'll come back when I have the Word file ready for you. Okay, so I've gone ahead and I've copied the information from this PDF into this Word document. And so what I'm going to do is now we can go ahead and get started. So the first thing it wants you to do is it's showing you that these students have conducted a dissolved oxygen experiment, and they've done cold water, hot water, and warm water. And they did 3 trials, and then they want you to find the average. So in order to find the average, I'm not going to do the math for, well, how about I do the math for the first one for you. Let me type this in red so you know that I was the one that did it, or that it's something that you're supposed to add. Okay, so once you get this information, I'm going to use my calculator right now. What do we have? 9.2 plus 10.4 plus 8.4, and that's going to give us 28. And since we had 3 values, so to get the average, we're going to add however many trials we have together. So that was 3, and we got 28. And so I'm going to do 28 divided by 3, and whatever that is that'll be my average. So that's 9.33. Okay, so you guys can do the other 2, and you'll do them exactly the same way. Okay, so once you've got that data, now we can go ahead and you're going to write a little lab report, and they've got each section already lined out for you. So that's pretty handy. So each of these sections is going to be in paragraph form, except for your procedures. If you want to put your procedures, if you want to number them, you can. And then also in your analysis section, you can number those as well. You can leave those numbered, that's fine. So what they want you to do here is they want you to discuss dissolved oxygen and water temperature. So what you're going to have to do is, I'm going to write this in red, you're going to have to research dissolved oxygen and water temperature. So these are some of the questions you're looking for. Does temperature affect dissolved oxygen? If so, does hot or cold or warm water have the most DO? Which has the least? Okay, so those are basically the kind of things they want you to talk about. And then you want to include a hypothesis. So you've already got your data here. So this is kind of a backwards hypothesis because usually you make your hypothesis before you do your data. But remember, your hypothesis is going to be in this format. Like, if I do this thing, then this will happen. Okay, and you're going to change whatever this is and this thing. Okay, so what did they do? If you do this, so they change the temperature, then what do you think will happen? Then the coldest water will have the most DO, or the hottest water will have the highest DO, whatever it is. So that's kind of how you write your hypothesis. Then it's testable, right? So if you do this, whatever you're changing, and then what you think those changes are going to cause. Okay, so that's kind of what you want to discuss in your introduction. And so since you're researching something, that means that you're going to need sources. Okay, so any sources that you found, you'll cite those here. So I'm going to write that, right? Cite your sources from the introduction. Okay, if you use the textbook page for the class, right? Remember we talked about page 8? If you use page 8 from the class, then you'll want to use that. If you used another source, you'll want to use that, but you want to put the link, definitely the link to the source. Personally, I don't care too much if you use APA, MLA. If you just write the source, that's fine with me. Include the link, that's fine. For your materials and procedures, the first thing they wanted you to do is, again, here's this word research, right? They want you to research how to calculate dissolved oxygen, and then they want you to describe a possible procedure the students might have used to gather the data in the table. So you're going to write a procedure, okay? You will write a detailed procedure as to how the students might have gathered the data in the data table above. Okay, if there's any particular materials they need, you want to write that. Okay, you could make a list of materials, include those, whatever the students used, and then you'll write a detailed procedure. And again, you can number that if you want. Step 1, they gathered 3 containers of water that were exactly the same size, and on and on and on. Okay, so like say that was mine. Gather 3 containers of water, or they actually probably used 9 containers. Remember, we want to keep as much as possible the same. Gather 9 identical containers and fill each with the same amount of water, right? And then, you can go on from there. You can talk about how you're going to heat some water, you're going to cool it, how you're going to measure the temperature, how you're going to collect the DO, that kind of thing, recording your data. Okay, so for your results, you want to calculate the average. Okay, we just did that, so we're good to go there. And then they want you to create a line graph that compares the temperature for your the temperature to the average dissolved oxygen. So let's do that. Let's go to Excel. Okay, here we go. Here's Excel. Now the first thing I'm going to do is I'm going to put my temperature, and I'm going to be 10, 45, 23, and then average DO, and I'll have 9.33. 5 and 12. Okay, these last two numbers, I made these up. Please don't use these numbers. I obviously haven't done the calculations. Okay, I just kind of want to show you how to make your graph. Okay, so I've got my data in here. So what I'm going to do is I'm going to highlight this, and it says make a line graph, but I think the best way to do this is to make a dot graph, and then let's make sure they've done it the right way. Okay, they've made the graph. Okay, so the thing that we changed is the independent variable. So that's going to be the temperature, and then the thing that responded to that temperature is the dissolved oxygen. So let's look. We have temperature numbers on the x-axis and dissolved oxygen numbers on the y-axis. So that's good. So we could do, you could write temperature versus dissolved oxygen. Okay. I'm going to click the plus here, and I'm going to put titles for each one. Okay, so for this I'm going to put dissolved oxygen, and what are my units for dissolved oxygen? ppm. So I'm going to make sure I include those, because we always want to put our units on our axes. And then for that we'll put degrees C. Okay. Okay, so here's our graph. Now we can add a trend line. Okay, so we could put something like that. So that's good enough. So remember, my numbers are wrong. Okay, the first one's right, but the other two are wrong. So just keep that in mind. Now I'm going to take this graph and I'm going to copy it. I'm going to hit Control C. I'm going to copy it, and I'm going to just, nope, that's not what I wanted. Let me go back to Excel. I'm going to take my graph, and I'm going to copy and paste it in here. There we go. Okay, so now I've calculated my average, right? I'm going to pretend I've done the other two rows, and then I've also done my graph. Now, just so you guys don't forget to do this, I'm going to write calculate this, and I'm going to highlight it. That way you don't see that it's blank and not do it. Okay, now what is our independent variable? We already discussed this, right? I just told you, because we checked on we made sure our x and y axes were correct. So our independent variable was the temperature, and our dependent variable, that means, was the dissolved oxygen. Was this a controlled experiment? Why or why not? Okay, you tell me. And then analyze your data and give a summary of how dissolved oxygen in sample water changes with temperature. Again, you want to discuss, you kind of want to answer these questions, right? Answer these questions in your summary. Okay. And right, do you see how we're coming full circle? We talked about this in our introduction. We got some background research that kind of discussed, we discussed maybe what might happen with our background research, and then we're going here in our analysis section, and we're seeing if our data agrees with the background research. Okay, so now for your conclusion, you're going to write a 4 to 5 sentence paragraph regarding what you learned. Okay, what you learning regarding temperature's effect on dissolved oxygen. And we're going to see how this enhances our understanding of the ocean and marine life, and then you'll cite any sources. Okay, if you need sources for your conclusion, you can use those here. Okay, you'll cite those here. Okay. Most of the time, most of your sources come from the introduction, but you may have a few from the conclusion. And then you'll also want to sort, for this one, since you're researching on your materials, you'll cite your sources from the procedure section. Okay, so these, because I said cite your sources, that means you have to do those, right? Those are required. And then if you have any sources from your conclusion, you can add those. Okay, so this is kind of what you'll do for your lab. I'm going to go ahead and I'll save this document and I'll post it in that newsletter for you. That way you can edit it. Remember, my graph is wrong, but at least it gives you an idea. Oh yeah, don't forget to put my graph there. Okay, and then hopefully this helps you do this dissolved oxygen lab.